Hi there, this is lecture 12. This is section 4.4 on the chain rule. So the chain rule is what we use when we have a function inside a function. So we have a 3x plus 4 inside a square. And so we want to develop a rule that we're going to call the chain rule in order to differentiate this. So right now we don't have a rule when it's set up like that. So let's think of it instead as 3x plus 4 times 3x plus 4. And then let's use the product rule. So let's call this our function 1 and this our function 2. And then function 1 is 3x plus 4 and its derivative is 3. And function 2 is 3x plus 4 and its derivative is 3. So when we put the full derivative f prime of x together, we get 1 prime 2, which is 3, times 3x plus 4, plus, again, 3 times 3x plus 4. And instead of distributing in combined like terms, I want us to think about the fact that this is two of the same things added together. So this is really 2 times 3 times 3x plus 4, okay? And I'm going to rearrange it for a second, and I'm going to leave the 2 out front, and I'm going to move the times 3 to the back, and I can do that because multiplication is commutative and associative, so I can group it and move it however I want. And then I want you to notice something. Remember that this came from the function f of x equals 3x plus 4 squared. And when we would normally see this square on the outside, we would multiply by a 2 and decrease the exponent by 1. Notice that happened. But I didn't touch the 3x plus 4 when I did that. But then I multiplied by the 3. And the 3 came from the derivative of the inside. So it looks like that my rule of thumb here is that I'm going to take the derivative of the outside, leave the inside alone, and then multiply by the derivative of what's inside. And that's exactly what our chain rule is going to state. Okay, so when we have a function inside a function, so you have f composed with g, and you're going to take the derivative of the f function, leave the g of x in there, and then multiply by g prime. Okay, and so again, the words here, we're going to take the derivative of the outside function, leave the inside alone, and then multiply by the derivative of the inside. Okay, so if I'm thinking about that with this example, instead of approaching it the way we did before, we would say, okay, well, the derivative, I'm going to bring down the 2, leave the 3x plus 4, decrease the exponent by 1, so I don't need to write it. And then we multiply by the derivative of the inside, and we get exactly what we got before. And so then I would simplify this and put the 2 and the 3 together to make it 6 times 3x plus 4. If you want to distribute the 6, you can, but factored forms are just as good for us as having it multiplied out. So let's take a look at some of the other ones. So here's another one. We want to identify that this is a function or polynomial inside another function, which is a power. So we're going to start with the blue one. We're going to start with the outside function. And we're going to bring down that 4, just as if it were on an x. We're going to leave that inside alone. So we are not changing that. Only change one thing at a time. So right now we're taking the derivative of the power. Then we want to multiply by the derivative of the inside. So we're going to multiply by 3x squared plus 2. And really, I can't combine anything. If you want to, you could take this one times this one, but you don't have to. You can leave it factored. Okay, from there, that was example 2. Example 3, another one. We've got a similar power, only now our power is negative. So we've got our inside function is the polynomial, and our outside function is the negative 2. So we're going to bring down the negative 2, decrease our exponent by 1, but I'm leaving the inside just as it is. My new power is going to be negative 3, and I'm going to multiply by the derivative of the inside. That's 15x squared plus 4x minus 1. Now, I do want to clean this up and make my negative exponent positive. So the negative 2 stays on the top. The 5x cubed plus 2x squared minus x plus 4 moves to the bottom so I can make its power positive. And then that last piece doesn't have a negative exponent, so that stays up top. Again, if you really want to, you can multiply out that 2, negative 2, but you don't have to. You can leave it nice and factored. All right, next we have 1 over the square root of 2x squared minus 1. First thing we're going to do here is we're going to rewrite this, right? So I have a square root, but it's in the denominator. So the 2x squared minus 1 is going to come up, and it's going to have a 1/2 power because of the square root and a negative power because it's in the denominator. Now I can recognize that I have an inside function and an outside function. So in order to take my derivative, I use good notation. I multiply by the power, leave the inside alone, and decrease the power by 1. Then I'm going to multiply by the derivative of the inside, which is the 4x. So here, I have negative 1/2, so the negative 1 is on the top and the 2 is on the bottom. My parentheses there to the negative 3/2 is going to go to the bottom, so 2x squared minus 1, so I can make it a positive 3/2, and times 4x up top. Now these two have a 2 in common, so I can cancel that, and I'm left with negative 2x over 2x squared minus 1 to the 3/2. Okay, sorry, I was just realizing that these are the same problems as the guided practice. That's fine. Okay, so in this case, I have 2 sets of chain rule. I've got 2 inside functions and 2 outside functions, and those 2 things are being multiplied. Okay, so because those 2 things are being multiplied, I'm going to start with the product rule here. So I'm going to start with a function 1 and a function 2. And the only time I would start with chain rule is if everything is to the same power, and that's not what's happening here. I have 2 things with separate powers, and they're being multiplied. So I'm going to start with a product rule. So function 1 is the x plus 1 squared. And so its derivative using chain rule, I'm going to bring down the 2, leave the inside. New exponent is 1, times the derivative of the inside, which is also 1, so I don't have to write it. Function 2 is the x squared plus 2 cubed. So to get its derivative, we're going to bring down the 3, leave the inside. New power is 2, and we multiply by the derivative of the inside, which is 2x. Now I can multiply this one and this one together. So that's 6x times x squared plus 2 squared. Now when I put this all together, this is 1 prime 2, so this is 2. Times x plus 1 times x squared plus 2 cubed plus 2 prime 1, so that's 6x times x squared plus 2 squared times x plus 1 squared. Okay, and that's my derivative. What I do want to do here, because this is kind of a lot of things, is I'm going to try to factor this. So if I look at what they have in common piece by piece, I have a 2 and a 6x, and those have a common 2, so I'm going to bring a 2 out front. Next, I look at the x plus 1, and the first term has 1x plus 1. The second term has 2x plus 1s. So they both have at least 1, so I'm going to pull out 1. Then if I look at the last piece there, this first term has 3x squared plus 2s. The second term has 2x squared plus 2s. They both have at least 2x squared plus 2s, so I'm going to pull that out. Now, what's left? If I look at the first term, I took out the 2, the x plus 1, and 2 of the x squared plus 2, so there's an x squared plus 2 left over. So that goes in the bracket. Plus. From the 6x, I took out 2, so there's a 3x left over there. I took both of the 2x squared plus 2s, but I only took 1 of the x plus 1, so there's 1 x plus 1 left over. And then in the brackets, I can go ahead and distribute and combine like terms. So that's going to give me x squared plus 2 plus 3x squared plus 3x. And that's 2 times x plus 1, x squared plus 2 squared. And then I'll have a 4x squared plus 3x plus 2 in my bracket. And I can leave my answer in that nice factored form. And then the last one for our guided practice is this one, where I have everything. In particular, I have this fraction all to the same power. So that means I'm going to use the chain rule first. Inside, I have a quotient, which means when I take the derivative of the inside, I'm going to need quotient rule. But I start with the chain rule because everything is to the same power. So I'm going to bring down the 2/5 power. I'm going to leave everything in the parentheses the way it is. I'm going to decrease my exponent by 1. Then, in order to get the derivative of the inside, I need a quotient rule. So we have that the top is x cubed minus 5, and the top prime is 3x squared. The bottom is 1 minus x squared. Don't forget when you take the derivative here to take the negative with the x squared. So this is going to be a negative 2x. So when I put this together, I want top prime bottom. So that's 3x squared times 1 minus x squared minus negative 2x times the top prime, which is x cubed minus 5, all over the 1 minus x squared squared. Now, the two things that I want to do here is I want to make that negative exponent positive, and I want to simplify and combine like terms in the numerator. So I'll keep the 2/5. Now, in order to make this a positive 3/5, I need the reciprocal, right? Typically, negative means 1 over, and 1 over something is the reciprocal. So I want the reciprocal of this fraction, and that means that I just flip it over. Then over here, I'm going to distribute. So 3x squared minus 3x to the 4th. This becomes plus 2x. So I'm distributing a positive 2x to give me 2x to the 4th minus 10x all over 1 minus x squared squared. And then I just want to combine my like terms. Combining like terms, I have a negative x to the 4th plus 3x squared minus 10x all over 1 minus x squared squared. And I'm going to leave my answer like that because that's pretty enough for me. And it's in a nice factored form. If you see that there's a 1 minus x squared with two different powers and you want to combine that, you can. But it's also totally acceptable to leave it just as it is.